Hi everyone. Thank you for joining us today for this event today. I'm Henry Che, the Executive Director for New Mobility Technologies, and I'm really excited to go through some of the work that we've been doing today. If I just run through the agenda, next slide. We'll just go through about the exciting work we've been doing on this today, and what we'll do is going through the different role and partners working on this project. Then we'll get to talk about the current need and priority from the key end user community, and then we'll have the technical team coming to join us. So actually talking about what the work we've been doing in contributing to the needs and the priority. And at the end of it, we would like to have some networking to allow to further question and explore what the next step could be. Next slide. So one of the, in simple terms, what are, before we go on to discuss more about the challenges, one of the biggest problem is communications, is the illusion that is taken in places. And by George, that in a nutshell, what we're trying to do on this project to just address this challenge. Next slide. This program is part of the UKRI funded Future Flight Challenge program, which is in partnership with Angoka, Cranfield, and the Connected Places Catapult. To look at some of the testing and finding that we have in the UAS authentication systems. What we'll go through today is actually how we provide the additional layer of devices authentications to ensure that the trusted device aerial platform are safe in flying without being tampered, which we'll explain much more later. Next slide. So if I just go through from a Connected Places Catapult, that for those who don't know us, we are the UK Innovation Accelerator for cities, transport and places. And we provide impartial innovation as a service for public bodies, businesses and infrastructure provider to catalyze step changes, improvement in the way that people live, work and travel. We connected businesses and public sectors leaders, and in this instance, we connected up the expert in the security domain from Angoka and looking at the UAS requirements and working with Cranfield that from both sides, understanding the unmanned traffic management challenge and the drone challenge, and actually how we connect the few of our organizations together in sparking and addressing the challenges that is going to be explained in a second. Next slide. What we'll do now is pass on to Professor Antonius to talk about the Cranfield University contribution on this project.
Thank you very much for the introduction. I'm Antonius Chordos. I'm leading the Center of Autonomous and Physical Systems here at Cranfield University. And for the few of you don't know Cranfield is the and only postgraduate university in UK with its own airport and navigation system. And we are very honored to be a part of this particular project of the Future Flight and working very closely with CPC and Angoka. Cranfield is focusing predominantly on the development of communication and networking for drone operations that will enable the safe integrations to the airspace. You will find out more details about our specific developments on this project by my colleague, Dr. Saba Al-Bayai. Thank you very much. It's already mentioned this one.
Hello. Apologies. Sorry. Hello, everyone. My name is Yuri Anderson, and I'm the CEO of Angoka. We are an IoT cybersecurity company, and we go to next slide, please. That focuses on smart mobility and smart cities. We have been around for about 3 years, and we got a headquarters in Belfast and with offices in London and The Hague. We're around 20 employees at the moment. And despite the 10 years, we have been working with a number of very high-profile organizations, such as the National Cybersecurity Center, where we've gone through the highly prestigious accelerator program. And also we've been supported by the Centre for Connected and Autonomous Vehicles, as well as NSIC, and of course Innovate UK, not just through the Future of Flight, but through a variety of other programs as well, including the Quantum Technologies program and so on. And we've also built a number of very fruitful partnerships, of course, with the partners here, Cranfield University and Connected Places Catapult, but as part of other projects, we have a wide range of partners as well. Next slide, please. So we are attempting to be the gold standard for IoT security, and we have that focus on ensuring safety and resilience of smart cities and smart mobility. And there's a very strong element of future-proofing that we have in our solution. So we have made sure that, for example, we have built our solution to be quantum secure from the bottom up, to ensure that whatever we put in place today will also last the course and stay relevant in the next 10 years plus. So this is a big part of what we do, and we do things differently from what is typically done today in terms of cybersecurity. If you go to the next slide, please. So really, the way we do things represents a paradigm shift in that we realize that the networks and the data links are typically untrusted. You cannot trust them, and this is more and more true when it comes to connected devices in general. You cannot always know where the data flows and in whose hands it ends up. So we are making that basic assumption about the data link that it cannot be trusted. And this is why we focus on tamper-proofing the identities of the devices, and this is how we create that trust in the communication between devices. And the other pillar of our philosophy is that anything that sits in a software layer can and will be hacked. So we've gone down the technology stack, down to the hardware level, and this is where we anchoring the security on a hardware level instead. And there are a lot of other features as well to our solution in terms of how we manage the security in a decentralized and dynamic way without the reliance on third parties such as certificate authorities. Next slide, please. And just to give you an idea of what those devices may look like, I've given a couple of examples here on the screen. We can deploy our technology in a variety of ways. One is through as a retrofittable device that you can see at the very top line there. We have connector boxes, we have USB sticks, we have network cards. All of that is to make sure that we can retrofit our solution to existing devices and therefore upgrade the security in a very quick manner. If we have access to the devices already at the design stage, of course, we can embed our solution. And this is what we've done, for example, for automotive electronic control units, which is the image you see on the left under point 2. The third option as well, we can deploy as firmware on secure elements. If there are things like hardware security modules available, then we can deploy on those or even trusted platform modules. But we do need to have some level of hardware security in place in order for our solution to function. Our philosophy is that when we secure a system of devices that communicating, the security can only be as strong as the weakest link. So we need to have every single point in that link strong enough. Next slide, please. So we really came from a land mobility angle, and we had developed solutions for land mobility. And what we've done as part of the Future of Flight program is really to take that technology, translate that into an air mobility and a UAV or UAS context and adapting that technology to those use cases. So we've been fortunate to been involved in 2 projects. One is Project Accelerate, which is led by BT and Altitude Angel and others, where the focus is more on establishing a drone corridor for beyond line of sight flying, and we will be integrating there specifically with the Altitude Angel system, and also in terms of communication, the focus is on 5G. That brings me to UASys, where the focus is slightly different. The 2 aspects of the same thing, but the focus here is much more on geofencing, about interfacing to more generic UTMs, and we've been basing that on the open access UTM framework, and also in terms of data links, we've been focusing mainly on Bluetooth and Wi-Fi communication. But the 2 of them have been working in tandem, and both of them have been extremely valuable for us in order to develop our technology. And that's is all for me. I think we'll move on next to show a short video.
Very pleased to be here today at Cranfield Airport to conduct the trials where we will be demonstrating successfully how Angoka's technology can be used to secure drone communications. Well, we bring our expertise in terms of cybersecurity. We have developed an innovative tamper-resistant identification technology that we can use in order to create secure drone communications. And this will lay the foundation for the secure and trusted and robust traffic management system for drones that we need to put in place in order to build the transport infrastructure of tomorrow. So drone transport can offer great benefits both to the economy and society at large. However, we need to put robust cybersecurity measures in place because otherwise we cannot ensure the safety of drone operations. And this is what Project UASys addresses, this issue, and Angoka alongside partners Cranfield University and Connected Places Catapult will demonstrate how we can build the secure systems of the future.
Here at Dartech, we are focusing on the management of digital data for the aviation sector, helping it become more adaptable to the future flight systems that are coming our way.
Connected Places Catapult is a UK technology and innovation centre, helping organisations to develop new products and services in emerging markets. We've helped Angoka access a new and growing market through transfer of their security technology from other sectors into the unmanned air vehicles domain. By sharing our expertise and understanding of the unmanned traffic management system, we've worked together to successfully integrate and deliver secure identification, tracking and authorization services. The technology helps to ensure that only trusted devices are operating in a UTM system. This is particularly beneficial where high levels of security and safety are required.
Cranfield University role in this project is leading on drone connectivity and system integration. We've been able to develop different technology scenarios to address current and future challenges of autonomous systems. We are incredibly proud to have worked with such a strong team to deliver Project UASys. This project brings us together as a consortium to provide technical solutions for drone network security against cyber attack, and also to accelerate shared airspace in a secure and safe manner. The solution we provided in this project is to examine the challenges and opportunities that introduce a new generation of drone connectivity.
Okay, good afternoon. So my name's Richard Holland. I'm the team leader for regulation, safety and B&B within New Mobility Technologies. I'm really pleased to introduce the next session. So I'm delighted to say that we're joined today by Tom Hodges, who's the head of counter-drone science and technology at Department for Transport, and Simon Masters, who's the deputy director for the Future Flight Industrial Strategy Challenge Fund.
So good afternoon, everyone. Hopefully you can see me and hear me okay. As you can see on the slide, my name is Tom Hodges, and I work at the Department of Transport, where I lead on counter-drone science and technology. I'm delighted to be here with you today to learn about the results of this Future Flight Challenge project. And I'm going to spend the next few minutes talking about some of the DFT's priorities in new aviation technologies, including the safe and secure use of unmanned aerial systems. I'm sure I'm preaching to the choir here when I say that drones are a rapidly developing area of technology with the potential to have a transformative effect on the lives of the public. To take a few examples, drones have been delivering medical supplies to remote islands during the COVID-19 pandemic, improving the connectivity of some of the UK's more remote communities. Drones are used to survey infrastructure, such as railways, improving health and safety by removing people from potentially harmful situations. Drones have been used by the emergency services, including the police, improving the efficiency and the quality of public services. And drone technology is rapidly developing with new industrial and societal applications that could be seen in the UK soon. Drones will also contribute to UK prosperity, with some estimates forecasting that the drones industry will bring an extra £42 billion to the UK economy by 2030, supporting over 600,000 jobs in the drone economy. So looking forward, the government wants to make use of new aviation technologies, including unmanned aerial systems, to transform the movement of people and goods and deliver tangible benefits to communities, to industry, and to users. We want to be able to offer new options on how people and goods can move around. But in doing that, we need to make sure that anything new is introduced in a way that is safe, secure, environmentally sustainable, and publicly acceptable. To do this, and to realise the maximum benefits of new aviation technologies, we're working to ensure that the necessary policy, regulatory, and legislative framework is in place by working with other government departments and the Civil Aviation Authority, as well as supporting the work being done by the Connected Places Catapult and Future Flight Challenge programs and projects, such as this UAS Authentication Systems project. Some of you may have seen last year's announcement from the Cabinet Office on plans to review EU regulations that were automatically kept on the statute books after Brexit, known as retained UK law. These regulations will be scrutinised by government to ensure they're helping the UK to thrive as a modern, dynamic, independent country and foster innovation across the British economy. The government plans to set out a package of individual regulatory reforms to laws inherited while a member of the EU, building on recommendations submitted to government by the Task Force for Regulatory Reform, Innovation and Growth. And in autumn last year, the department launched a consultation on the future of transport regulatory review, with one of the priority areas being the future of flight. This regulatory review aimed to address areas of transport regulation that are outdated, a barrier to innovation, or not designed with new technologies and new business models in mind. The department is currently analysing the many responses we received to this consultation, and once this analysis is complete, we'll be publishing a government response. Talking now more specifically about drones, despite all of the positive benefits that drones offer, if drones are used negligently, maliciously, or are otherwise interfered with, they can also be used to cause disruption, commit crime, undertake an act of terrorism, or be a safety risk to members of the public. For example, the 3-day closure of Gatwick Airport in December 2018 is reported to have caused travel disruption for hundreds of thousands of passengers and tens of millions of pounds of economic damage. It's also well publicised that drones have previously been used to deliver contraband into prisons. And there are also a wide variety of other potential drone risks that we must protect against in order to enable a safe and secure drone sector. The safety of crew, passengers, and the general public remains the priority of government and the regulator when considering the introduction of any new or novel aircraft in the UK. And accordingly, it's important that any new or novel aircraft are introduced in a safe way. Safety and risk management processes are well established in the aviation sector, but new or novel aircraft may require a new approach. Recognising the core principles of aviation regulation, new or novel aircraft will need to meet the highest levels of safety. We want to ensure that any vehicle operating in UK airspace is subject to an appropriate aviation safety framework. And to support innovation and ensure that these new vehicles can be operated safely and securely, we're considering what amendments to UK legislation may be necessary. We will also need to ensure the cybersecurity of individuals, businesses, and the UK as a whole in relation to new and novel aircraft, in order to protect the development of new technology markets. This includes both national security and ensuring individuals, communities, and businesses are protected from abuse, malicious actors, or unlawful interference, however caused. We will also need to consider what, if any, measures are necessary to ensure the security of related systems that enable this new aviation technology, such as UTM. So I'm really looking forward to hearing more this afternoon about how this UAS authentication system project can help contribute to a safe and secure drone sector in the UK by ensuring that the communications critical to controlling and flying drones are protected. I'm especially pleased that this project is a collaboration between an SME in industry, a leading research university, and the Catapult Network, and it's collaborations such as these that will enable the UK to continue to be at the forefront of aviation innovation. I'd like to thank all of the parties in this consortium, Angoka, Cranfield University, and the Connected Places Catapult, for all of your hard work in delivering this project. And of course, I'd also like to thank my colleagues in UK Research and Innovation for their support both to this project and the wider Future Flight Challenge. And on that note, I'm going to hand over to the next member of this panel, Simon Masters from UKRI.
Thank you, Tom, for those kind words, and good afternoon, everyone. A great pleasure to have the opportunity to speak to you today, and indeed to hear more about what this project has achieved. Whilst we have quite a few projects now in the Future Flight portfolio, it's always great to be able to come and witness firsthand and some of the great work that you've done. So very much looking forward to that. So yes, we'll have the next slide, please. And we'll go one more, actually. Thank you. Great. So conscious that some of you may well know quite a bit about the Future Flight Challenge, but also there have been some changes, and some of our work has evolved whilst this project has been running. So I will touch on a brief reminder about the programme, but also cover some of the new aspects and perhaps looking more towards the future as well. So the Future Flight Challenge really got going in earnest in 2019. And runs through until 2024 and is a £300 million programme looking at the future of aviation. So very much looking at new vehicles, so drones, urban air mobility vehicles, and passenger aircraft that are featuring electric, hybrid electric, hydrogen, or any other sort of non-traditional propulsion systems. And very much looking at those vehicles themselves, but also a lot of the enabling systems and capabilities that are needed to safely and effectively introduce those vehicles into service in the future. Next slide, please. So what does that mean in practical terms? And again, some of these examples Tom has already alluded to. So it's things like the use of drones to deliver medical supplies effectively, in normal operations, and indeed in disaster relief scenarios. And we've had, as sadly we do most winters now, evidence recently of flooding in parts of the UK, and indeed perhaps opportunities in the future for drones to play an even greater role in supporting those sorts of disaster relief operations. Drones can also be used where the use of humans to carry out maintenance or inspection tasks puts them in harm's way. So offshore wind farms, the UK has increasing numbers of offshore wind farms, and they are often located quite far offshore. So the use of drones as an enabler for inspection and maintenance tasks could well reduce health and safety challenges to those tasked with their ongoing maintenance, and also provide a better way of keeping them going in some of the very challenging environments that they exist in. One of the other key parts of the program as a whole is about connectivity for people, for goods. So new forms of air transport with the sort of AAM, eVTOL type aircraft now becoming a very much a reality and not just a sort of a dream, very much coming in the next sort of 5-6 years into full service. And indeed, we're seeing some of the prototype aircraft now flying in the UK and across the world. Drones can also be used for deliveries. We haven't tended to focus on as much on that in the Future Flight programme, recognising that others have done that in other countries perhaps. But we're very keen on integrated transport systems. So rather than developing new forms of transport in isolation, how do they link into other forms of public transport? And how do they allow those to live in the more remote parts of the UK to better access the same sorts of services that the rest of us enjoy? Next slide, please. So you may have seen this chart before. It really shows the progression of the challenge as we move sort of left to right. But we're always keen to sort of talk about not just about the funding. I know funding is really important. It's something that we're very delighted to be able to offer, and it does sort of help to support some of the innovation and the collaborative activities. But actually beyond that, there are a number of other activities we're doing, working closely with the CAA and commissioning a lot of studies. Some you may have seen already. The ones towards the right of the screen are perhaps newer ones. So we're doing quite a lot of work at the moment on social science research. And again, perhaps some of the aspects from this project may well feed into that in terms of how assured the public feel about the safety of drone operations as their usage increases in the future. We're going to launch a number of industry working groups. There was one an announcement just made earlier today about an airspace modernisation working group that's going to be set up to look at some of these issues and really help coordinate some of the activities as we move forward. And as always, recognising that as an agency of the Department for Business, we are very much interested in the economic and business aspects as well as the R&D aspects, where we can provide additional financing and scale up support to companies of all sizes. Next slide, please. So as part of that, we've commissioned and issued a number of studies, and in fact, we will continue to do so. And whilst we focus on the success of projects, some of which may be sort of completing in the next few months, we're also very keen, and everyone is aware that a lot of this work will continue even after some of our projects have finished, and we very much welcome your continued and ongoing support and input to various studies as we release them over the next months and years. And really, your support and insights is what makes these various reports as valuable as they are. Next slide, please. As well as that, we've used our position as a public sector body to really convene a lot of collaboration and to work with organisations who, for us, sometimes are quite new. This is just a selection of some of the people that we've been in touch with. And one of the things we have tried to do is to make those introductions where projects, where companies have really been seeking out new partners or new sources of information or possibly funding. We've very much tried to act as a sort of introductory service, if you will, helping organisations to connect with some of the bodies you see there. There are many more and many more probably that we still have the opportunity to introduce people to. Next slide, please. This is a slide my boss came up with. Clearly, I'm not quite clever enough to talk to it exactly, but it really shows. We've somewhat arrogantly put ourselves in the centre of the universe there. It really shows some of the complexity of the challenge we face, but also the tremendous opportunity we have interacting with various public sector bodies, government departments, DFT, amongst others, industry itself, and the various working groups, trade bodies, and organisations, regulators in the bottom right, regulation and indeed standards we're now looking at, and our research councils are sort of part of UKRI, but still very valuable in providing some of the input they do. And really, one of the key challenges we see is actually how do we use all of those organisations to help us with our road mapping activity, which you may have seen, but also how do we help companies and projects succeed through the sort of the mass of knowledge and capability that all of those organisations shown there represent. How do we make the output more than the sum of all of those parts? Next slide, please. So looking perhaps a bit more specifically on cybersecurity, on communication systems, on UTM, the future flight landscape is complicated. We've looked at the sort of 3 vehicle types in the centre there, but there's a whole range of enabling technologies that are needed to bring those aircraft and those vehicle types into the sort of safe usage. It's one of the things we used to joke about, perhaps not so much now, that cybersecurity used to be a sort of a buzzword, and every time we'd review project applications, we'd always see cybersecurity amongst other phrases used. It was very seldom that actually there was any meaningful attempt to include or explain what cybersecurity aspects these projects were going to cover. It seemed as if that was organisations felt it was the right thing to do to mention cybersecurity in their R&D applications, and that's why it's actually really pleasing to see a project such as this one that has devoted itself in a kind of structured and detailed way to addressing some of those and looking at them in a very sort of detailed way as to what that means and how the use of drones really depends on getting that bit right and really getting the security systems, the communication systems right. Otherwise, the sort of introduction of these drones into UK airspace will be much, much more challenging. Next slide, please. We've been having some workshops with NASA recently to kind of share our experiences. NASA are running a lot of similar programs in the US, and so it's helpful for us to speak to them, to understand their approaches, and to share information where that's appropriate. So I very much did steal this slide from them, and it really demonstrated a lot of what happens is not actually about the vehicle or about the airport or the ground system. A lot of it is about communications between vehicles. I'd be hard pressed to name too many of our projects that are actually focusing on some of these elements, and perhaps that is something that we need to look at. But I'm very pleased that this particular project and the group of organisations that we have with us today are very much at the forefront of looking into some of these aspects, as I say, and some of these very important challenges that we face before drones can be sort of safely introduced into widespread usages. Please don't ask me what all of those acronyms are. The guys from NASA did very much talk me through this slide, but my memory being what it is, I probably can't remember exactly what all of them mean. But hopefully it kind of gives you the flavour, certainly of how they saw it, but also I think it illustrates that a lot of what's needed and a lot of the key technology work that's still required is very much not about the vehicle or where it's delivering to. It's very much about the communication system and how those vehicles will operate safely within a modern airspace environment. Next slide, which I think is my last slide. Good. So I think we're moving on to a Q&A session. So I shall hand on and we can hopefully get that started.
Great, thank you. Thank you, Tom and Simon, both for some very insightful and interesting presentations. So, yes, as just mentioned, we're going to be entering in a few moments. We're going to be entering a Q&A session with Tom and Simon, which I'll be chairing. So, on your hop-in screens, for those of you that may not have used this platform before, to the right-hand side of the screen, there is a Q&A panel. So please feel free, if you have any questions for Tom or Simon, please feel free to type them in there. I'll get through as many as possible in the time that we have available. I can't promise to address them all live, but we'll try and answer as many as we can, and perhaps certainly follow up on some of those that we can't. But before we do that Q&A, we're going to also ask you to complete a couple of polls for us today. So again, in the same area on the hop-in page, there is a polls option, and you'll see some polls launched. So the first one, so we can launch the first one, Leanne. So we're going to ask you how well you think cybersecurity for air mobility is currently addressed? So it's a fairly straightforward poll, yes or no answer really. So it's actually the lower poll on the screen there. So is cybersecurity for air mobility currently adequately addressed? Yes or no? If you could let us know your answers to those questions, it'd be useful to get your views. The second question we'll be covering later on, so please just answer is cybersecurity for air mobility currently adequately addressed? And I'll give you a few seconds to do that, and we will have a look at the results. Okay, so hopefully you can also see it changing live. Give people a few more minutes to find where that is on the screen if you need. So as I say, it's towards the right hand side of the Hopin main page in the right hand pane, and just click on polls under the event. Okay, so we're currently, interesting answer. So it seems like this project is serving a very valid purpose. 90% people currently who have voted do not think that cybersecurity is adequately addressed. So as I say, that's quite reassuring from the project point of view in terms of what we're trying to do. I think maybe, Leanne, if we can leave that poll open for a little while, we'll get into the Q&A to see if other people have had a chance to I'll give people a chance to vote, and we can maybe look at the final numbers at the end. So yeah, as a reminder, I see some questions have started to come in. I will give a few more minutes for you to ask your questions, but I'm going to start with a couple for Tom and Simon, if I may. So we'll start with Tom, if I may, please. So you spoke about some of the risks that drones could pose to the UK, as well as the benefits of a safe and secure drone sector. So maybe you could tell us, what is the government doing at the moment to support the drone industry by protecting against illegal drone use?
Yeah, of course, and hopefully you can still hear me and see me okay. So yes, as I said earlier, the government wants to see drone use in the UK that's safe, that's secure, environmentally sustainable, and publicly acceptable. And so to do that, we need to tackle malicious or negligent drone use, which we'll achieve through a layered approach, blending both the technological innovation, but also legislation, regulation, and education too. So the government's strategy for protecting against illegal drone use is set out publicly on the gov.uk website. So that's the UK Counter Unmanned Aircraft Strategy, and I'd recommend that everyone goes and have a look.
Great, thank you. So Simon, what are some of the wider steps that can be taken to advance the state of the art in authentication systems?
I think that there's a lot that can be learned from other sort of adjacent sectors. So I think Yuri mentioned earlier about CCAV, so Centre for Connected Autonomous Vehicles. So I think that there's a lot of similar challenges for autonomous cars as there are for drones and other autonomous aircraft. So I really think it's helpful to look more broadly at where this sort of challenge is faced. And I spoke about collaboration earlier, and anything we can do to introduce people, perhaps even from more of the military side, in terms of some of the encryption approaches, and just think where does expertise already exist, so that we're not trying to sort of solve a problem that's already been potentially addressed elsewhere, and really look at what other organisations, public sector or an industry, may have some expertise to bring to this. Fully appreciate that the organisations want to work on their own or with partners and develop their own IP, but I think there's a real benefit also in sharing approaches for these sort of joint challenges that we face.
Thank you. So I guess to follow up from that, and what plans are there for supporting those companies that are looking to develop these sort of systems?
So I think it's contained within our roadmap that we issued last year. So there's a sort of an action plan that we're putting in place as to how we can help organisations address these, who we need to get involved. We're also, perhaps at a more simple level, we're looking at collaboration events with our existing portfolio of projects, getting them together. I think actually the next one will be in person, which will be great, and really giving people the opportunity to share what some of these are, and with, I guess, some prompting from us. So where we see some of the bigger challenges like authentication and UTM systems, really getting people together and saying how can we solve this, and just really trying to bring all the expertise to bear where we can, and clearly involving Tom and his colleagues at DFT and making sure that we sort of including all the right people in those discussions.
Okay, brilliant. Thank you. I'm just going to quickly look back. Just a reminder as well to the audience. Please do type in your questions in the Q&A on the Hopin main page. Just for information, we can probably close it now, but the poll of the 27 votes, so 92.6% of people here today think that cybersecurity for air mobility is not currently adequately addressed. So again, quite an interesting and certainly a convincing opinion amongst the audience. Okay, so we have a couple of questions in the Q&A for the panel. So I'll read the question out, and then maybe I guess probably both Tom and Simon give you both an opportunity to answer. You can hopefully see the Q&A yourselves as well, so you can get a bit of an advance notice. But so first question, submitted anonymously. So in a recent NASA event, the 100 experts were split equally between the pace of development and autonomy. So the question is, how does the Future Flight Challenge resolve such differences when even the EASA, the FAA, and the CAA differ on their approach? So maybe Tom, perhaps if I can start with you, your thoughts on that one.
Yeah, it's an interesting question. I'm not sure I've got an answer straight away. I think we've got to always be looking towards the future to see what different kind of possible futures we see, and what actions we can put in place now that will provide some benefit across multiple kind of different futures depending on where the technology goes. I think I'll pass over to Simon to see if he's got anything else more to add.
Not particularly. No, it is a great but tough question, and I guess in the discussions we've had, it's perhaps not a surprise that there is a real sort of balance of views, and that's one of the things we've tried to do with our roadmap and other documents we put out there, is not to say that we know the answer, is just to say this is a kind of collected view of the various experts we've consulted, but very much to put it out there for discussion and say there may not be a consensus at the moment, but actually we need to talk about these things. And if people agree or disagree, that's great. Let's have a conversation about it. Let's see where we go. And then that's perhaps what we're seeing with, as I say, the various different groups, EASA, NASA, various others all seem to having slightly different views on this with no clear path. I think that we're at that stage of having those conversations now, which was what makes it quite exciting in some ways.
Great, thank you both. So a couple more questions come in as well. So a question from Alex. Thank you, Alex. So how do you keep costs down such that the UAS industry remains economically viable and it's not just a technology demonstrator? Margins are obviously tight, with million costs being brought into the picture. So Simon, perhaps if I can start with you on this one.
Yeah, I mean, it's very true that a lot of the use cases for the use of drones are based on some fairly slender margins, and that the benefits that can be brought do rely on a sort of keeping costs to a minimum. If we talk about transporting goods, that's very much the case, that we need to be aware that low-cost land transport solutions do exist and will continue to exist, and they will become increasingly green, so that the benefits of flying things by drone may not always appear quite so compelling. I think, yeah, there is very much an onus to create a sort of operational framework where drones can be operated as cheaply as possible. I think anything to do with aviation is always attracts a certain premium just because of the complexities of flying. But I would hope that we can find a way, and actually some of the volumes that many consultants are talking about in terms of the number of drones that they're expected to be operating within the next 10 years will hopefully keep those costs down in many ways.
Okay, thanks, Simon. Tom, anything you'd like to add to that one?
No, nothing more on that one from me.
Okay, thank you. So moving on, still got a couple more in here. So from Nikos, thank you for your question. So are or will there be different authentication requirements for US depending on the application scenario, taking into account, for example, operation over cities versus over agricultural areas? Again, a good question, probably a very difficult one to answer. I think we may get more information on that actually in the next session after the break, when we get into the technical, the more technical presentations from the project team. But I mean, I guess I'll first open the floor to Tom and Simon, if you think there's anything you'd like to add on that. Tom, perhaps. So do we think there'll be different requirements depending on the applications?
I think in terms of kind of the cyber security of drones and contributing towards a safe and secure drone sector, we need to protect against sort of unlawful interference or malicious actors, however they're caused. So really, I'm looking towards the session this afternoon to find out more about how this project can help contribute towards this in kind of all environments.
Okay, thank you. And Simon, anything to?
I think there's obviously a desire to have a kind of as simple a system as possible, a unified UTM system with the same sort of standards and approaches. I don't know personally whether that's practical or whether we will need different levels of security and authentication depending on where operations are taking place. And like you, looking forward to hearing more about that from perhaps people who are more experts a bit later on.
Yeah, so hopefully Nikos will hopefully go some way to give you a bit more insight into that later on after the break. Okay, so there is a question regarding future funding, and Simon, obviously, I think you touched on some of this in your presentation, but I just wonder if there's any more information or insights available with regards to kind of the next phases phases of Future Flight Challenge.
Yes, so we've just about sort of concluded the process for our phase 3 competition, which we did some assessment process and interviews. I say earlier this month. I think they were technically at the end of January, and we're just waiting for sort of the final set of approvals before we can make some announcements about that, and indeed until those who've applied can have the results of that shared and the feedback with them. So that will hopefully be announced very soon. And then beyond that, goodness, it's taken a lot of work to get to that stage. I think we'll sort of perhaps draw breath over the summer, and then really see. Having looked at the projects that we've currently funded, having looked at these new ones, and really kind of referred to our roadmap and other publications, see if are there any gaps, is there anything else we need to do to sort of meet the output of our program, and then obviously working closely with BEIS and DFT to make sure that we're delivering against various other sort of government programs and the sort of the future of flight consultation that DFT have been doing, just to make sure that we're supporting all of the various sort of other government activities.
Okay, thank you, Tom. Finally, is there anything you'd like to add on this one?
Nothing from me here. I think Simon's covered that.
Okay, thank you. Well, okay, so there are no more questions in the Q&A. Yeah, Tom, Simon, I'd like to thank you very much for joining us this afternoon, both preparing and delivering the presentation, also sitting on this Q&A panel, which I know can sometimes be very difficult, especially when it's such a small panel. All the questions come at you, so very much appreciate your time. Actually, sorry, just a late one in before we do close this session. So the last question from Julia, just come in a few seconds ago. And I'm afraid it's probably coming to Simon first. Where does Future Flight Challenge overlap with ATI and the work that they're doing on green technologies?
I don't know if I'd say whether we overlap. I mean, the ATI is a much larger program. I mean, I forget that they've quoted sort of billions of pounds over the years that they've been operating, and their annual budget has been it's quite substantial. And their focus has traditionally been on supporting the likes of Airbus and Rolls-Royce and the sort of 100-seater plus passenger aircraft. I think clearly recognizing the direction aviation is going, they are also funding some more green aviation projects. I guess the simple difference that we see is that they're much more focused on the vehicle and the vehicle technology, and we're much more focused on the vehicle operating within a new kind of ecosystem. And so the infrastructure, the UTM systems, all of the other enabling technologies that are required. So we do work with them quite closely to understand our kind of respective portfolios and make sure that what we're offering is clear to applicants. And I would hope, for fear of being kind of contradicted, that we do kind of offer sort of complementary support to businesses who are looking at different bits of the aviation ecosystem.
Okay. Brilliant, thank you. So that definitely is it. So once again, thanks to Tom and Simon for your time this afternoon. So we're going to go into a short break now. On the agenda, it does say a 5-minute break. We are due to restart at 5 minutes past the hour, 5 minutes past 2 for those on UK time. Suggest we stick with that time, start time, so we'll give you slightly more than a 5-minute break. So a 10-minute break, and we'll reconvene with session 2 at 5 minutes past the hour, where you'll be hearing from the project team about the technical development and field testing of the UAS authentication system. And again, that will be presentations followed by a Q&A session. So again, please feel free to take the time to think of some questions you might like to ask the panel as they're speaking. And again, we will have a second poll for you at the end of that session. So yep. So with that, we'll take a break. We'll be back in 10 minutes at 5 minutes past 2. Okay. Thank you very much. Okay, well, welcome back. I hope you all enjoyed your break. So welcome back to session 2 of this afternoon's event. So as a reminder, this is the technical project team going to be talking to us about the technical development and field testing. And as I said before the break, it will be followed by a short Q&A. So keep those questions coming in. And again, there'll be one more poll at the end of the day. So first of all, I'm going to hand over to my colleague Konstantinos, who will introduce you to the CPC contributions to the project.
Thank you very much, Richard. Hello, everyone. My name is Konstantinos Malandrakis. I'm a senior system engineer at Connect Place Catapult. Next slide, please. Well, how many of you have ever asked a question or heard about public acceptance in a US event, working group, or workshop? One of the most popular questions is how to consider or achieve public acceptance. Public acceptance is key to facilitating the integration of a new technology or a service in an environment. In the US domain now, safety and security are essential principles that can foster the general public acceptance. In this project, we use some of the security values identified in the use space course report, for example, the integrity, availability, confidentiality, to assess the security level of the USAS. In particular, the Angoka technology can authenticate information of local communications or UTM services. With respect to the availability, by duplicating the current software authentication and hardware, the Angoka technology will ensure redundancy and add an extra measure to prevent disruptions in communications and UTM services. Furthermore, a hardware authentication device such as the USAS could support or could add a layer of protection of a confidential or private safety information. Last but not least, the USAS device could flag up to key actors, for example, an enforcement body or maybe an airport, when a US becomes a risk for a critical infrastructure or enter an airspace volume without permission. Therefore, the USAS is not only a security device that prevents hackers from cyber attacks and other activities, but it's also a concept that could foster the public acceptance of a US operations. Next slide, please. Great. The USAS device is the first UK hardware US authentication device and one of the first UK remote ID add-on devices. This device comes with some key features. For example, this device is compliant with existing AST standards and has the potential for the ASTM standards. One of the key features is that the USAS device can be integrated into many UAV platforms, either as a standalone add-on device for private built US, for example, or as an embedded system integrated into off-the-shelf US. This technology can be integrated into various backend systems that we're going to analyze in the next slide. However, there are two main options: locally, using the Angoka hardware and the one that we're going to present today, or on a cloud, using a standard available cloud-based hardware security modules. Next slide, please. So last year, Connect Place Catapult, in collaboration with DFT, CAA, and industry stakeholders, demonstrated the open access UTM that enables multiple service providers and US operators to operate in the same environment in a safe and efficient manner. In that work, we defined key open access UTM actors, interfaces, and services. As we mentioned in the previous slide, the USAS now technology can be integrated into various backend systems. So like having authenticating the communication between a US operator and its platform, or another local communication or interface between the UAS and someone external, like a public authority or enforcement body, or maybe someone who's using it for its own area, like an airport. So in this project, we will focus only, as I said before, only in the local areas, and this is marked with the highlights with the orange box. In order to answer the question that Nick raised before, it seems that for different let's say for different cases, for different environments, for different services and actors, and we probably need different type of technologies. For example, different authentication methods. As we said before, we can maybe have the Angoka hardware that we're going to present today, or we can have the cloud one. However, the technology is there. So based on the different elements, I believe that we will be able to authenticate successfully. So if we go to the next slide, we can focus on the area that this project will mainly focus on. So we're looking for two interfaces. The first interface is the interface between, as I said before, the pilot and the US platform. So mainly we authenticate the control and command and the telemetry data. On the other end, we have the second interface, which is mainly we authenticate the remote ID, the broadcast element of the remote ID. So up next is Tim Harrison from Angoka, who will provide more information about the USAS device, the system architecture, and the field trials. Thank you very much.
Thank you, Konstantinos. Good afternoon, everyone, and thank you very much for joining. I'm Tim Harrison, and I'm the engineering lead for Angoka. In this session, I will take you through a technical overview of our technology and its implementation within the scope of the UASIS project. Next slide, please. So what are the main challenges when we look at UAS security? Well, to be effective, UTMs must be able to confidently identify, verify, and monitor participants within the ecosystem, and particularly the dynamic component, which is the unmanned aerial system, or UAS itself. When we look at Project UASIS specifically, two of the main areas that introduce vulnerabilities are the direct remote ID standard, which includes almost no authentication for messages, and Mavlink, a common messaging protocol for command and control, which doesn't include a secure method for key generation and exchange. If these mechanisms are exploited, it could allow unauthorized users to impersonate legitimate UAS or send potentially damaging messages to the system and other participants. Next slide, please. The use case that we focused on for UASIS was a smart port. The port is a single entity, privately owned, spread over a large geographical area, and to achieve coverage uses several local base stations, or what we're calling monitoring stations, to receive the remote ID messages and communicate to the UAS using Mavlink. The port itself owns several UAS for surveys, and there are also third-party UAS providing perimeter security. Next slide, please. Decomposing this use case into a system architecture, we have the UAS operated by the smart port. We also have UAS operated by the third-party provider. In the center, we have the ground control station, which consists of the operator, the Wi-Fi connection, and ground control station software used to control the UAS. In this system, both UAS send remote ID messages to monitoring stations throughout the site, and these monitoring stations then relay the remote ID messages back to the ground control station over Ethernet for display. I should mention here that this architecture does not include a cloud-based UTM element, but for this implementation and for testing, a representative UTM is running locally on the same device as the ground control station. But later we will see how Angoka's technology could be implemented as a cloud-hosted service. It's also worth noting that Wi-Fi and Bluetooth have been used here for control and remote ID. Now, we're involved in another future of flight project, Project Accelerate, that aims to use cellular. But for this project, we're focusing on local communication for a single site, such as a smart port, hence Wi-Fi. Wi-Fi is well known, it's a standard, easy to set up and configure, and it's easy to integrate into corporate networks. You will see in later slides that Cranfield have done a lot of work here looking at the range and handover of Wi-Fi for this project. Just back one slide, please. Thank you. Of course, cellular is not currently included in any remote ID standard, both US or EU, and Ofcom does not currently allow cellular modems in the air without special permission. Again, another reason why we focused this particular project and use case on a local scenario. Mapping attack vectors onto this architecture, we have the remote ID itself, that's the Bluetooth. We have Wi-Fi telemetry and comms. We have the Ethernet between the monitoring stations. We have the ground control station. And of course, we have introduction of unauthorized or spoofed UAS into the system. Next slide, please. As part of the Angoka project, we completed a full threat analysis of the system. The highest risk threats, highlighted in red, focus on the identification and communication of the UAS, such as forged direct remote ID messages in transit, direct remote ID message implementation on the device itself, and Wi-Fi injection for UAS takeover. These are the highest risk because of the high impact, since they can affect the safety of a flight and cause risk to human life. The threats in bold are those that Angoka's technology can fully protect against, and the threats in italics are those that Angoka's technology can partially protect against. Next slide, please. So the proposed solution consists of 3 parts, which we'll look at in more detail. The Angoka Ranger, an electronic conspicuity device, the Angoka Watcher, a Bluetooth monitoring station, and Angoka Protector, which is an interface into commercial ground control station software. Next slide, please. The Angoka Ranger, at this version of development, is a test and development platform, not a product. The product will come in version 2. It's an electronic conspicuity device that conforms to EU standard EN 4709-002. The Ranger routes Mavlink and telemetry and command and control messages directly to the flight controller. It incorporates a secure processor running Angoka's patented technology, and it ensures secure key generation and distribution within the system. Next slide, please. Angoka Watcher is a monitoring station that receives the Bluetooth remote ID messages. It routes these messages to a ground control station over Ethernet, and it's outdoor IP rated and mast mountable. For the field trials, 3 Angoka Watchers were positioned to cover the test site. Next slide, please. The Angoka Protector is a software application, and it provides 3 functions. It interfaces with commercially available ground control station software, such as UGCS. It provides ground-based authentication of remote ID and Mavlink 2 messages within a trusted hardware environment. And it enables configuration of geofences and alerts depending on the UAS authentication status. The Protector application running locally on the ground control station is a local representation of the Angoka system. In future implementations, this will be available as a cloud-hosted service that can be accessed by other services. Next slide, please. So revisiting the system architecture after integrating Angoka's technology, we have the UAS and Ranger. Ranger incorporates what we refer to as a DAU, or a device authentication unit. This is a hardware element that enables our technology. We also have discrete DAUs in a USB dongle format connected to the monitoring stations and the ground control station, enabling hardware-based authentication. We can see the ground control station, which is running the ground control station software, UGCS, and now crucially, Angoka's Protector application. Again, as mentioned previously, this is hosted locally for the trials, and in future implementations, this will be cloud-based and integrate with cloud-based UTMs. Next slide, please. So the capabilities that we aim to test during the project were direct remote ID, both the transmission of standard remote ID messages using our Ranger unit and the reception and display of those remote ID messages within UGCS. Crucially, we also aim to demonstrate secure end-to-end remote ID authentication. For Mavlink, we want to secure generation and distribution of keys to allow end-to-end telemetry message authentication and end-to-end command and control message authentication using Mavlink 2. Finally, all this builds together, and we aim to demonstrate a UAS access control system based on ID, authentication status, and configurable geozones. Next slide, please. So here we can see some images of the actual testing. In the top left, it's the drone in flight. In the left image, we can see the ground control station. In the bottom, we see the drone itself with the Ranger attached. The UAS used was a Hexoon quadcopter with a PX4 Q-Barings flight controller provided by Cranfield. And on the right-hand side, we can see the ground control station software, UGCS, with the Angoka protector integrations. Next slide, please. For the results of the testing, specifically looking at the direct remote ID, we had a successful implementation. Messages were sent at 1 Hertz, 1 per second, as per the EU standard. Our authentication technology added 0 latency to this message rate, and authentication was added within the existing messages in line with EU standard. No additional messages had to be added. It's important to note that Bluetooth 4 was used due to component supply issues. However, although Bluetooth 4 is included in the EU standard, the range and coverage was relatively poor. One of the main outcomes of the project will be to move to Bluetooth 5. For Mavlink, we enabled Mavlink 2 authentication within the existing Mavlink protocol. We achieved an Angoka configuration and setup time of 3.5 seconds. It should be noted that that time only happens during setup and configuration and happens at the start of a flight. After setup, we add 0 latency. Also tested was the Mavlink 2 authentication itself, which caused 28 microseconds of latency. Next slide, please. Once our technology was integrated into the system and the testing complete, the threat assessment was re-evaluated. Of the threats that we protect against, we reduced the top 4 significantly, those referring to the UAS communication and ID, with the total risk score reducing from 112 to 66. Next slide, please. So in conclusion, the main outcomes from the project were we developed a full threat assessment both before and after integration of our technology, design of the Ranger development platform, and development of a watcher unit to enable reception of remote ID at range. We used Angoka's technology to support key generation and distribution for authentication of standard remote ID messages, and also in conjunction with Mavlink 2 to provide message signing and authentication. We created Angoka's software application protector to integrate our technology into commercially available ground control station software, such as UGCS. And we developed and tested a UAS access control system based on authenticated remote ID and geozones. Next slide, please. Thank you very much. I'll hand on to the next speaker.
Thank you, Tim. Good afternoon, everyone. I am Saba Rubai, Leader in Autonomous and Connected System. I'm leading Advanced Connectivity Research Group at Cranfield University. Next slide, please. In order to unlock the full potential of commercial UAS operations, it's important to find a way to safely integrate unmanned aircraft in a shared airspace. So Cranfield University was able to design and develop communication data link and to provide a solution to Angoka security product with aviation system to enable a new class of autonomous air system. A comprehensive assessment has been completed by Cranfield for UASA platform selection for the drone, communications technologies, data link requirements. We've been able to identify different mobility scenarios and provide performance analysis for signal handover challenges. Next slide, please. Since the drone using wireless communications, we expected some of the key challenges in wireless networks, such as signal fading, mobility, data rate enhancement. It could be interference, security, a big issue, and also quality of services. So communication infrastructure, I would say, present a significant challenges here. So the network must be able to support mobility and local resources to the given drone. So the infinite resources of the network must be allocated fairly and efficiently to meet the changes of the drone demand and locations. For such air-to-ground drone wireless communication scenario, so the handover are expected here to occur. So the drone may not be able to exchange data packet when performing a handover. So the handover delay become critical in guarantee real-time applications to meet the quality of service requirements. Next slide, please. Different communications requirement has been defined by Cranfield in the UAS networking to ensure the system reliability. So as you can see from the tables in this slide, which introduce the technology metrics to reflect the quality of service requirements. Also, Cranfield University was able to provide a high-level diagram for the whole system integration. So the scenario is modeled for urban environment, where usually there are required, I would say, a ground-based station to support the UAV in a such urban environment. So UAV is moving across urban area through different cells, so the handover will be occurred here. Handovers means is the mechanism that allows the drone to move from one network to another one without losing connectivity. There is some standard here. So IEEE standard doesn't define the handover process for UAV, especially for the vertical handover between heterogeneous environment. But it does describe basic process for reassociation of the signal. From this particular problem, lead us to conduct some analysis about the drone mobility to support reliable data link, I would say, for air-to-ground connectivity. Next slide, please. So at Cranfield, we use NetSim simulator for system performance. NetSim is a new network simulation or simulator for drone applications, network design validation, and research development. So we use here Wi-Fi technology has been implemented in this particular simulation. So Wi-Fi performance metric has been calculated by employing full stack Wi-Fi simulator and analysis the impact of different communications factors such as the delay. For the system analysis, we've been using different routing protocols such as UDP protocol, TCP protocol, and do comparison between them in terms of the data link reliability. So the figures here shows the end-to-end data rate in a multi-hop UAV with the ground station networking. We observe from this analysis that the UDP has very high fluctuations compared with the TCP, which is in the right figure. So I would say TCP here is more reliable than UDP for air-to-ground testing. Next slide, please. As I mentioned, so Cranfield was able to provide a system integration. So the high-level diagram here shows the system integration between different components that has been provided by Cranfield University, such as the drone. We use a drone Hexason, which is multi-router. One of the biggest advantage of the multi-router drone is their maneuverability compared with a fixed-wing drone. So this will enable the drone to fly in the area other drones cannot reach it. Also, multi-router, the reason that we use multi-router here, a drone, is more suitable for a wide range of applications, such as a drone for last mile delivery, I would say. Another more important component that has been used, which is a flight controller. We use Pixhawk Orange Cube, which is an industrial control system. It has very powerful process, and it offers very good performance, and it build also with some security features. Another component we use also Raspberry Pi with external antenna, which is a small computer we embedded on board of the drone, and we use it for purposes to for the payload transmission and to measure the signal to noise ratio. We use also a ESP radio transceiver modem on the board of the drone for the command and control issues. As you can see from the high-level diagram, on board of the drone, we have embedded two cards. So at first, the first card was to measure the signal-to-noise ratio with using external Wi-Fi adapter, and that has been used. The adapter was embedded within the ground station, which is the computer in our case, and the radio ESP Wi-Fi modem has been embedded on board of the drone. To enable this measurement for air-to-ground data link, we use HomeDel software in order to record the logs for the received signal during the flight. The second one, which is the Wi-Fi router on the ground station, has been used in order to enable connectivity with a Raspberry Pi. So the measurement can be done using this technology or this product to measure the throughput, the delay, and extra other quality of services for the communication data link. So the system operation will gather and record the data, whereas the pilot will be responsible and focusing on the command and control during the flight. Next slide, please. Again, different software has been provided by Cranfield as well in order to enable the testing. So this has been used, one of the software has been used in the ground stations for mission control, and the others has been used in the test field trial on the board of the drone in order to measure the signal-to-noise ratio and in order to record the logs as well. For example, HomeDel software was very useful in order to enable us to record the logs and measure the signal-to-noise ratio between the ground station and a drone during the flight. Next slide, please. So I would say, following a successful integration of hardware and software, we've been completed a successful, I would say, field trial using quadcopter at Cranfield Airport. So the figure here in the field on your left-hand side shows the location of the ground station, which is a laptop, for both horizontal and vertical flight for the range and direction. So the 350-meter horizontal communication range has been set and used as a maximum point due to the fact that the longer distance may be collide with the airport path and may exist the typical Wi-Fi distance as well to enable communication connectivity. In addition, 120-meter has been set as a maximum vertical point for the drone that this point has been set to meet the UK regulation of the drone. So the received signal strength performance of the communication link has been investigated here in the field by means of HomeDel when the drone vertically moved away from the ground station in the key target. So in summary, I would say this development will be a key point to conduct cutting-edge technology research to enable safe, secure, and sustainable operation of the drone in a sense. So by this, I think this is the last slide from my side. We can go to the panel.
Okay, thank you. Thanks, Saba, and also thank you to Tim and Konstantinos for the preparation and presentations in this session. Hopefully, that's provided our audience with a really insightful understanding of what the project has achieved. So, yeah, so we're going to spend the remaining 20 minutes or so with the Q&A panel. So, a reminder, and for anyone that may have joined since we did this the first time, on your hop-in main screen on the right-hand panel, you've got a Q&A tab, so feel free to type any questions in there. I will get through as many as possible. May not get through them all, but we'll try and follow up any that we miss. We will also later on be launching the second poll, so again that will appear in the polls part of the event in the same area of the screen. So I guess I'll start with a question, probably mainly for Tim and Konstantinos with regards to the different standards. So you've talked a lot about remote ID and Mavlink. So really, what are the industry standards for US security, and which of the remote ID and Mavlink standards do you comply with? So Tim, maybe to start.
Yeah, thanks. Good question. So I think in general, there are very few, if any, security standards that specifically relate to UAS or the comms. With regards to the remote ID, there's the European standard that we focused on for this project. It's currently released in draft version, I think. That includes a very basic 3-digit code for authentication, which, by the admission of the EU, is not really to prevent a determined individual. It's more to stop the man next door. So that's why we refer to it as virtually no security on those messages. The US standard has a specific message for authentication within the remote ID messages. This is the direct remote ID. But again, they don't provide anything specific in the standard for signing those messages. So it's up to the implementer to pick the mechanism by which that's performed. That's on the remote ID side. When we look at the Mavlink side, which is the protocol used for command and control and telemetry to and from many drones, standard Mavlink doesn't include any authentication mechanisms whatsoever. I think it was 2017, Mavlink 2 was introduced, and that includes authentication based on SHA-256. However, it doesn't provide a mechanism for secure generation and distribution of keys between elements within a network. It simply provides the authentication within Mavlink, and you need to pass it the key that you have generated. The methods prescribed in the current standard or in the current protocol, they suggest doing it over fixed USB or cabled, or using a USB dongle to transfer keys, which obviously isn't ideal on a large scalable system.
Okay, thanks, Tim. So I suppose Konstantinos, to follow up on that, obviously Tim talked a lot in the presentation about remote ID, which has been the main focus for the device in this project. In your presentation, obviously you showed a number of the services within an open access UTM framework. So kind of beyond this project, what do you think are some of the other services that could be authenticated or protected in this same way within a UTM standardized set of services?
Yeah, I think there are many opportunities there. I think the UTM services, they are providing an element of authentication. Most of them already do that. The key, and this is the point of our work here, is that we add an extra element, an extra layer of protection, which creates redundancy in the system. And this is because we are using also a hardware component. So most of the service, they include this software authentication, but in our case, we're adding this hardware piece that will give us an extra protection. And that's why we drop down, as Tim presented before, the risk. So, yeah, I believe both remote ID, both standards on remote ID are great. They have very good points. We have the opportunity to test the direct remote ID with Angoka this year, and last year we had the opportunity to test the STM standards around network remote ID. They both perform very well. They're open, and they're it's very key for the industry to grow and create more support the remote identification. Now, with regards to the other services, I think again there is opportunity to add the hardware piece, as I presented, either on cloud or as a hardware module that the team presented. However, we need to consider some key elements like who is the actor, what is the operating environment, and also what is the service that we are talking about.
Okay, thank you. And then, really, surely a malicious drone, or an operator of a drone who wanted to cause damage or disruption, just surely wouldn't transmit remote ID. So how do we protect against that, Tim? Tim, you're muted, I think.
Somebody had to do it once.
Yeah. Gotcha.
Whenever you're integrated into a larger system, there's obviously just there's more than just a remote ID in order for detecting drones. I mean, if you take our smart port use case, if you visually see a drone, and I know there are other projects working on other drone detection, specifically drone detection systems as opposed to ID systems. But if you detect a drone and it's not transmitting a remote ID, then that's your red flag straight off. So yes, if you're relying just on remote ID in terms of detecting drones, that could create a problem. But I think that's the differentiator really between remote ID and drone detection. Remote ID is for identification, and some of the other systems on the other future flight projects that exist, they're for detection. And if you're securing a critical site such as a smart port, you really want those both working in tandem.
Okay, thank you. Saber, I'll come to you if I may. Just sort of thinking about the broader sort of aviation industry. So how do you think the new development of this technology will impact the future of the aviation industry?
Thank you, Richard. This is a really good question, I think. I would say due to the constant increase in security and immigration of air-to-ground communication to the digital data, so the current, emerging, and future communication system are facing definitely a tremendous challenging to provide efficient data link with the suitable capability, availability, and system integrity. So for me, Project UASAS will help to improve security and data link reliability by making flight planning and operation more efficient and secure.
Okay, thank you, Saber. I'm going to come to a question from the audience now. So thank you, Richard, for submitting this. So what range did you achieve for the direct remote ID? Tim, that's probably going to come to you first, I think.
Yeah. It varied. It varied obviously on location, on where the ranger was mounted on the drone and the orientation of the drone. So of course it varies by a lot of those things. But really, on our testing, the Bluetooth 4 struggled to reach 100 meters. Now the EU remote ID standard suggests that Bluetooth 4 can receive 250 meters, and maybe that is true in a lab-based scenario. But we only really, in practicality, achieved 100 meters. The advantage with Bluetooth 4 is that it's widely accepted, so it's supported by any current device, smartphone that there is, or device, including iOS type devices, whereas Bluetooth 5 isn't currently, or certainly wasn't when we started the project. But I think that, like I say, one of the main outcomes is to move to Bluetooth 5 that has a much greater advertised range.
Okay, thank you. I guess kind of a connected question, perhaps, sort of thinking about sort of rural situations, Saber, where mobile receptions and the like might be limited. So what are the requirements for drone communications within the a rural remote scenario?
Well, I think the requirements for long-range communications, including data rate, bandwidth, let's say, bit error rate, availability, latency, security, and so on. Definitely additional communication technology needed here to support the beyond, what we call it, beyond visual line of sight connectivity. to support the rural area. We may need to provide satellite communications capability here, because satellite communications can support the drone while flying in the rural area, as the ground infrastructure will not be sufficient in the rural area to support the drone flight environment. Yeah, that's my question would be. So satellite communications needed here. We need more capability, more requirement features to embedded satellite communications capability. So the drone need to communicate regularly with the satellite and hand it over from a ground station to the satellite in order to support this type of environment, rural environment. Yeah, in this project. In this project, mainly our focus was in the city, which is urban environment, but that was it could be an extension for the project or for future, investigation or looking in another program. Then we can extend it to look at how the handover can be done between the ground station and satellite communications. How to integrate the system together, because there is a lot of challenges, especially there is no standard till today from IEEE 3GPP to support the handover between the ground infrastructure and the satellite. This is the challenging here. It's going to be very challenging how to integrate this system together to produce maybe a new idea, novel idea, new algorithm need to be embedded on the board of the drone in order to enable this type of technology. Yeah.
Okay, thanks. Tim, did you want to add something to that?
Yeah, I think Zaba just makes a really good point, where especially for UAS, you can't rely on a single communications medium. There always has to be a fallover, and certainly I know of other projects and discussions going on, looking at other things like LoRa and SATCOM as fallovers. But again, consideration has to be given, as somebody asked earlier in the panel, about cost. And if you go to satellite, there's a huge impact in cost, and there has to be a balance between the two. But certainly fallover options in terms of communications is going to be essential going forward.
Okay. Yeah, I totally agree with you. The costs will be an issue here, but sometimes we cannot avoid it. In order to provide continuous connectivity to the drone or aircraft in a rural area, we need to move to the satellite connectivity. So this is maybe the point, yeah.
Okay, thanks. Konstantinos, I'll come to you with a question if I can. So let's say you saw or observed, let's say, an unauthenticated drone within a UTM system. So what could then be done about that?
So I think because the enforcement body will have will be alerted directly. I think there will be some measures in order, first of all, how to counter that drone. So we have faster and also more reliable information for the bodies. Either it's a public authority or maybe an airport. So overall, this will, first of all, will reduce many factors like cost, risk, and safety.
Okay, thanks, Konstantinos. Tim,
I think,
can you
just to add to that one, again, somebody mentioned Gatwick earlier in the discussion. And I think one of the main problems with Gatwick is, in the report that followed, was they weren't actually sure whether it was always the same drone. And they also sent up additional drones to find the malicious drone. And sometimes members of the public reported the police drone as the malicious one, which then created further panic and caused the thing to go on. And that really demonstrates the point where ID and a verification and authentication of drones is really the first step in this process. You have to know what's flying. You have to not just know what its ID is, but you have to verify and authenticate that ID so you can be sure where it's coming from. And that's really the first step in the process of sort of the, dare I coin it, the UAS kill chain.
Okay, thanks, Tim. You mentioned also, Tim, the Ranger. Obviously, it's kind of a early phase development, but so the size and the weight of it quite big and heavy at the moment. Sort of what are the plans for future development?
Yeah, absolutely. So anybody that was paying attention to the pictures, it's about You get the scale from my head, it's about that size. And I think it's in about 300 grams or 250 grams at the minute. So it's very much a development platform, and that was deliberate. There's a lot on there in terms of connections, interfaces, modules, debug and test to allow us to use it for that. And very much so going forward into the version 2, which we hope to develop on the Future of Flight Phase 3 project. It will be streamlined and reduced in size. But very much there's scope to do that from where we have. Really, this version was just a development platform to test the functionality and prove the principle. In terms of the technology that we run and the hardware that's required, we run on basic, so relatively low resource constrained microcontrollers. Really the hardware specific element we need is a hardware security module or some secure memory. But in terms of the device itself, we don't need supercomputers and we don't need laptops. We can run on pretty small devices. So size isn't linked to our technology or what we do. It's just more the development platform aspect of it. So a version 2 that's focused on size and weight could certainly be a lot smaller and a lot lighter.
Great, thank you. Okay, so we've got just 4 or 5 minutes left. Time for a few more questions, but before we do that, I'd like to launch the second poll. So as a reminder, if you go to the right-hand pane of your Hopin browser tab, there's a polls menu. So if you click on that, and thank you, Leanne. Yes, the second poll of the day. We'd like to kind of now understand if your awareness has improved as a result of what you've seen and heard today. So has your awareness of cybersecurity issues for air mobility improved as a result of this project? So again, an easy yes or no answer. So please, if you can answer that question, give you a few minutes to do that. We'll leave the poll open. Just got time for maybe 1 or 2 more questions before we come back and look at the results of that. So I suppose, Tim, I've got a drone. I want one of these devices. How can I get it?
Well, you definitely don't speak to me because I'm a very poor salesman. So yeah, absolutely. I mean, we have supplied. We said these are development systems, but we have supplied a number of them to a couple of different customers who are interested in testing the technology. So absolutely, we can do that and just get in touch after.
Okay. Thank you. So just checking this. Yeah, any more questions from the yeah. Ooh, okay, yes, a couple more questions coming actually. So let's just take these very quickly. So from Bill, in the UK, could the existing blue light communication system, so Tetra, be used for remote ID? Konstantinos, I don't know, are you able to take that one?
Yeah, just I think first of all we need to specify what are the specs of this device. If it's operating the same frequency that the broadcasted remote ID, for example, and a few other bits and pieces. However, I don't see issues of integrating the remote ID in the Tetra technology. But probably team have more information about how we can do that, how we can achieve that. But again, it really depends on how the Tetra can support that.
Okay, I don't know if either Tim or Saba can add anything to that, your knowledge of Tetra.
It's certainly a very interesting point. As a wireless communications network that already exists for remote ID, so it's certainly an interesting point. In terms of our technology and integrating within the remote ID, I mean, as we demonstrated on the project, we operate over Wi-Fi or Bluetooth or cellular. So really, the wireless mechanism really doesn't matter to us. And certainly in terms of the Tetra network itself, yeah, it's an interesting point. But I'm not an expert in Tetra.
Okay, thanks. So then the final question will be the final question from a anonymous submission. But what opportunity is there for a UTM provider to be involved in the future projects? I guess it's a get in touch kind of answer, isn't it, Tim?
Yeah, absolutely. I mean, if you're asking me, yeah, it's very much get in touch. Stay around for the networking sessions. We'll have some conversations. And I know in the Future of Flight 3 projects that we've submitted for, we are involved in one with a with an existing UTM. So we've already done that. Happy to encourage some more.
Brilliant, thank you. So we are at 5-2 now. So let's just take a look at the poll. So I asked you, has your awareness of cybersecurity for air mobility improved as a result of the project? Of the votes, we've had 17 votes, so 82% say yes, it has, and 17.5% say no, it hasn't. So again, a good, good result for us. Obviously, we've had some success in improving knowledge, and I think combined with the results from the first poll, hopefully we've shown that there's been some good added value from this work. So I guess before I hand over to Henry to close the session, once again I'd just like to thank all the panelists, so Tim, Saba, and Konstantinos for your presentations and for answering the questions on the panel this afternoon. So thank you.
Thank you.
I'll
Thank you.
hand over to Henry. Thank you.
Hi. Thank you very much. It's been fascinating hearing from you all, sharing the information today. I hope today that we have heard from Tom from DFT and Simon from UKRI about the need and challenges for the secure UK UAV communications and the government priorities. I hope you also get it from the project team has told us about the novel technical solutions, providing confidence by providing additional layers of device authentications to ensure that only trusted device aerial platforms are operating within a particular airspace types or unmanned traffic management airspace, which solves some of these, which enable us to solve some of these challenges, enabling unmanned aerial platform to safely fly without cyber attack and from being hacked. We ask for your view on cybersecurity risks and the need for authentications, which support the reason why we are doing this project. And the data is showing that quite confidently that what we are doing here is on the right track and providing a lot of thoughts into you guys. Today we have, we hope we have provided you awareness of cybersecurity issues and the air mobility drones improved it as a result of the development we shared, which provide a lot of food for thought and inspirations. And I'll encourage you to after this or even after later today, when you have your cup of tea, coffee or dinner, if you have any more food for thought in how we can work together to make future flight into reality, would be really grateful and see how we can make this all into reality. Thank you everyone for attending. And I also want to thank all the speakers for giving their time to both prepare and delivering these presentations and the finding we have. I also want to thanks for Gail and Leanne, who've been working in the virtual backstage in making sure this event running really smoothly today. I will also want to mention that we have the online networking is now available on this side of the button of the screen that you can click on, which you can and spark conversation with people that you have not met before, or actually on the left hand side where you can click on people and actually have direct messaging and communications of further conversations. Thank you very much for you guys attending today, and I'm looking forward to hear from you again soon.